Wait, there's more.
Blocking, intermodulation and cross-modulation, third order intercept. That one always used to get me, but I almost understand it now. Desensitization and preselectors. Okay. One of the most commonly mentioned, and I've never heard anybody mention it, is blocking dynamic range. Because we sometimes talk about amateur radio at our breakfast meetings, but we've never talked about blocking dynamic range. It's the measure of how strong an interfering signal has to be, reference to the noise floor, to reduce the strength of an incoming signal by 1 dB. In other words, put it into compression, where you start being nonlinear. So it's defined as the difference in decibels between the noise floor and the level of the signal that will cause a dB of gain compression. And all that's very confusing, but you only have to know the definition. What is meant by the blocking dynamic range of a receiver?
It's alpha.
Yeah, that's the only one that has a dB of gain compression in it, which is probably an easy way to remember it. Intermodulation. So if you have a device that's nonlinear, your receiver, your amplifier, a rusty copper or a rusty pipe joint somewhere can act as a nonlinear detector and generate intermodulation products if it's receiving signals. So it takes two signals and some nonlinear circuit or device to create intermodulation products. The one that we care about is the third order. And for two reasons. One is the thing they call third order intercept. And then the other has to do with how close the third order components are to your reference signal. And it turns out that the third order, being farther away, has some intermodulation products which happen to be the closest to your actual carrier level. So they define here simply the third order intercept is the level at which the third order intermodulation product will reach the level of the signal being received. And the third order, in the linear region, for every dB you increase the gain, your input signal is going to increase by 1 dB. At the same time, the third order signal is going to increase by 3 dB for every dB. So since they have different slopes, obviously at some point of gain, they're going to intersect. And that's what they call the third order intersect. Although they tend to round off before they ever get there, but they kind of extrapolate the lines and do that stuff. And you see that in specifications for receivers. They specify the third order intercept, and the higher that is, obviously the better, the lesser the intermodulation products. So in this example, we've got a pair of 40 dBm input signals which it says theoretically generate a third order intermodulation product the same level as the input signals. So since the third order increases at 3 dB for every dB, it's going to intercept it at some point. They won't be parallel. And the third order, which is really the first odd order set of products, turns out to be the one that is closest to your carrier or your signal of interest. And I think there should be another chart here. So if you've got two signals coming in to your nonlinear device, you're going to get these four products out. You're going to get the two signals, and you're going to getting 2 times one of them minus the other. So you got 2W1 minus W2, or 2W2 minus, and these are omegas, not W's. So this is important when we look at some of the stuff coming up, is to remember it's 2 omega 1 minus omega 2, or you could say it's 2F1 minus F2, and 2F2 minus F1. This is showing our F1 plus F2 are this center band for the second harmonic, and they're well, basically there are 3 products for those, 2F1 and 2F2. If we look at the third over here, okay, we've got our 3F1 and 3F2, which are true third order harmonics. And then you got the intermodulation products, which is the 2F1 plus F2 and 2F2 minus F1, because we also have the negatives, which are way down here. The 2F1 minus F2 and the 2F2 minus F1. And it turns out that those are the same distance from these two desired outputs as this distance between them. So it's very hard to get rid of them, even though they are reduced amplitude. So that's why we care about the third order harmonics, because this set of products turns out to be almost adjacent to the signals that we want. So what is the term for spurious signals generated by the combination of 2 or more signals in a nonlinear device or circuit?
Intermodulation.
What causes intermodulation in an electronic circuit?
Nonlinear circuits or devices.
Yep. So what does a third order intercept of 40 dB mean with respect to receiver performance?
Charlie?
Charlie.
Just because you said it increased.
Yeah.
At a 3 dB level,
Right.
3 dB,
Right.
and the other is what, 1?
1 dB per dB when it's linear. Now, why it goes up at 3 dB per dB, I don't know. That's beyond the scope of this test. I might look at that sometime. So what are the odd order intermodulation products created within a receiver of particular interest compared to, why are odd order of particular interest compared to other products?
The odd order products of 2 signals in the band of interest are also likely to be within the band.
Right. They're the closest ones. Desensitization if you got a strong nearby signal, it can reduce the sensitivity of the receiver. It somehow affects the dynamic range, and I won't say that I
Sorry.
really understand all of this, but I believe them. I'm not sure how it works. But it can also cause spurious signals due to cross modulation. And I guess part of it is we're overloading the receiver or the A to D.
Yeah, there's times I get like a nulling effect and I have no idea where it's coming from because I don't see any signal nearby. But it's just like the whole, like there's somebody,
It's dark matter.
somebody next door that's got a transmitter, just wiping everything out. I don't
I don't know. But one of the things you can do is decrease the RF bandwidth, which means you put your filter or pre-selector or whatever on. And it might reduce the signal enough that you stop having that effect. So what's the term for a reduction in a receiver sensitivity caused by a strong signal near the received frequency?
Desensitization.
When we talked about that in the general on FM, it was just called overload. Which of the following describes problems caused by poor dynamic range in a receiver? Yep, cross modulation is the key there.
It shows it because it says desensitization.
Yeah. Which of the following reduces the likelihood of receiver desensitization?
Alpha.
Alpha. Okay, and a pre-selector, its whole purpose is to increase the rejection of unwanted signals outside the desired band. So basically, it acts as a bandpass filter. What is the purpose of a pre-selector?
Increase rejection of signal.
Charlie.
Desired band. Is there an echo in here?
That's like something I heard like 10 seconds.
Yeah.
Yeah.
It was a long path echo.
That was the gimme question. That won't be one on my practice test.
I like those.
Yeah, what I'm gonna do on the 11th, if anybody's here, anybody wants to go over anything, but I'm going to put together a test from hell.
No.
50 questions of the worst ones I can find.
Sounds like fun.
So if you can do that one, you shouldn't have any trouble.
I won't be here.
Intermodulation and cross modulation can also happen in final amplifiers or linear amplifiers. Now, it says that you can have intermodulation interference if you've got two repeaters, if they're in close proximity, and somehow those signals get into the final amplifier of the repeaters, which says to me their shielding and stuff isn't very good, but anyway.
Grounding.
However, the signals get in there, they can mix and cause these intermodulation products. So if you've got a receiver on 146.7 megahertz and you got a nearby station transmitting at 146.52 megahertz, you might hear signals on 146.34 as well as 146.61. Okay, I said, fine. So in their example in the book, they're doing 2 times the 146.52 frequency minus the 146.34, which they came up with an example, and showed that they were equal to 146.7, which was where the receiver was tuned. So you're hearing that product. Then they took 2 times the 146.61, which they said you might also hear. Of course, they never explained how they came up with those 2 numbers, and subtracted from the other station, the 146.52, and showed that it was also at 146.7. So you do hear both of those, the 146.34 and the 146.52. Now, how you determine that is a little different issue, which we'll get into, I think, on another question. So how can intermodulation interference between 2 repeaters occur?
Bravo.
Yeah, Bravo sounds good.
Somehow they get in there. And if they're in there, they're a problem.
Signals
We
mixed.
certainly didn't discuss airplanes passing overhead.
No, what do they do?
Signals.
Okay, now here's the nasty one. So what transmitter frequencies would cause an intermodulation product signal in the receiver tuned to 146.7 when a nearby station is transmitting on 146.52?
So you gotta.
So you
double-
either have to remember those 2 frequencies or you have to know how to work it out.
Do you double one of the highest frequency, or what? Double the highest and subtract the other one? Is that how
Well-
you did it? That's heavy math. So what's the,
This one might be on my test.
because it fits the definition of,
I had trouble with this one. In fact, I worked it out, but I'm still not sure I agree with them. But, you know, they're always right, so.
Alpha.
so what happens if you,
You say alpha?
Yeah.
yes, I won't.
Yeah, just out of curiosity, I'm working it out anyway, just to see how it lines
I
up.
just wanna see if 146.7
Michael's right. So,
2 equals
So it's 2 times the lower
minus.
minus the higher.
well, that's why it confused me, because you can't look at the third order products. Remember, 2 times F1 minus F2 and 2 times F2 minus F1. That doesn't work. It works for one of them. It doesn't work for the second one.
I took the average of 146.70 and 146.52, which gives you 146.61. And
Right.
that was the only one answer that had 146.61 in it.
And I worked it out by taking 2 times the F3 signal, because it's unknown, okay, minus the 146.52. And we know it has to come out equal to 146.7, because that's where you're going to hear it. So I solved for F3. So that's where you get F3 is equal to the sum of those 2 divided by 2. Now, that's how you can work it. I still don't completely understand it and why it's not the other third order product.
Note to self, memorization question.
I happen to be looking at the AARL book on this, and they do explain how to do this calculation. It's a lot.
A lot of calculation.
Yes,
Yeah.
it's a lot of calculation to do that.
This is one you might have to count as one of your 13 misses
Committed to memory.
or committed to memory. Well, we've probably talked about it enough. You'll probably remember it.
Just remember A.
No,
No,
no.
can't do that.
What
The
transmitter
question from
frequency?
L is A.
Okay. That was not the same question, right?
Yeah, it was.
Okay. Okay. A properly terminated circulator. I'm gonna have to go actually see a circulator. Michael,
No, I don't know.
why I didn't ask the question yet?
You're going to ask me about circulators, and I don't know.
Well, I want you to take me up to the penthouse so I can see your circulator.
Well, you can't get up there because you got to have the right training to get in the E-tower to get up there.
Well, I can take the training.
Yeah, you could.
All right. A properly terminated circulator at the output of a transmitter may reduce or eliminate intermodulation interference in a repeater caused by another transmitter operating in close proximity. So it's one of those trying to get in. I guess maybe they can get in on, from the way the circulator works, signal on the output. Because that's what the circulator does, is it blocks that. It's normally a 3-port directional device. And don't tell me how they work inside, but it has an input port, and signals coming in on the input port are routed to the output port. Any signal coming in on the output port gets routed to the third port, which is normally connected to an internal dummy load or an external dummy load. And from what I understand, these things typically have about 17 dB or so of signal rejection. And you can cascade them. So you can get 30 something dB by putting a couple of them together.
Does it just add like a negative image to it and?
Like I said, I don't know how it works.
eliminate it?
I don't know how it works.
You know?
It's magic. It's like a directional coupler. I don't understand how those work either.
My book says a circulator is a one-way valve that shunts off signals coming down the transmission line. I assume that means from the antenna to the repeater,
Right,
and sends them to a dummy load properly terminated.
right. And all the stuff I found, there are 3-port devices, even though one port might be internal with an internal dummy load.
Right.
It routes input to the output and output to the dummy load. So
Yep.
it's kind of like a directional coupler. But like I said, I don't understand how it works. It might be one of those things like a cavity filter where it's really magic.
Yeah.
But anyway, which of the following may reduce or eliminate intermodulation interference in a repeater caused by another transmitter operating in close proximity?
Properly terminated circulator.
Baker. Bravo.
Okay. Oh,
Is that it?
did I have the circulator picture in there?
I didn't remember that.
Well, got lost somewhere because I found one showing the in and out.